So now what I'm going to do is I'm going to explain how you would go about computing the LCM for multiple positive integers. So let me explain something. There are three methods that we know about. Method number one was simply the list. Method number two was simply the formula. And method number three was the prime factorization. I'll just put PF for now. You cannot use the formula because the formula is only valid for 2. So not with that. The list, we can use the list, but it takes a lot of time. And I'm going to say that it has a time constraint. You could use the prime factorization and it's the best option. So now that I've explained that the method that was the best to use is prime factorization, let's look at as an example the numbers of 2, 3, 4, and 5. So first off, as I said before, we need to break them up into their prime numbers. 2 is a prime number, so I don't have to break it up into anything. 3 is another prime number, so I don't have to break it up into anything. 4 is not a prime number, so I have to break it up into its prime numbers, which are 2 and 2. Then I have 5, which is a prime number, so I don't have to break it up into anything. Next, what I do is I list each number. Sorry, I shouldn't say really that I list each number. I should say that I list each prime number in this set of numbers so that I can be able to obtain the number I had. So first off, I start with 2. 2 is this number here. I only have to list it once. Then I have the number 3. 3 is this number here. I only have to list it once. 4 has 2 2's. So therefore I have to have 2 2's in my answer. Now this is my answer here. 2 2's means that I have 1 here already, so I have to multiply by another 2. Then I look at 5. 5 is by itself, so I put 5. Now notice, I can take all of these factors and multiply them in a particular way so that I can get back my answer. For example, let's look. I can say 2 multiplied by itself would give me 2. Sorry, I should really say 1. 2 multiplied by 1 will give me 2. Now, 1 is not a prime number, which is why I did not list it here. Then let's look at the next number, 3. Multiplied by 1 would be 3. Then I have the next number, 4. Now notice 4 has both 2 and it also has 2. So 2 by 2 will be able to give me the 4. And then for the last one I have 5, which is by itself, and I'll be able to get the 5. Now all I do is just simply find the product of each. 2 by 3 is 6, 2 by 5 is 10, 6 by 10 is equal to 60. And the answer for the LCM is 60. Now I can notice that if I take 60 and I divide by 2, I will get 30. If I take 60 and I divide by 3, I will get an answer of 20. If I take 60 divide by 4, I will be able to get an answer of 15. And if I take 60 divide by 5, I will be able to get an answer of 12. Notice that the numbers that are remaining, there is no common prime factor between them anymore. Notice 30, 20, 12, 15. You may start thinking, okay, well maybe 3, but number 20 is not divisible by 3. Let's look at another example just so you can understand this a little better. Let's say, for example, we have another list of factors. Let me choose some larger numbers now so that you can see what it looks like. Let's say, for instance, we have 10 and 15, and then we go all the way up until 25. Now, all we have to do is separate each one of these numbers into the prime factors. So I'll start with 10. 10 has numbers, prime factors of 2 and 5. Next we have 15. 15 has prime factors of 3 and 5. Next we have 25. 25 has prime factors of 5 and 5. So whatever answer we have must be able to at least cover these digits that we have here. So first off, we start with 10. 10 has 2 and it has 5. So those are the first two numbers that I put. Next, it has 3 and 5. I already have a 5 here, so I simply just put a 3. Next, we have 5 and 5. I already have a 5 here, so I just simply put one more 5. And now when I work out the LCM of these values, I would say 2 by 5, which will be 10. Then I have 3 by 5, which will be 15. Product of those two is 150. Notice, however, that each one of these numbers can be combined so that I'll be able to get back each one of the individuals on the list. So 2 by 5 will be able to give me back my 10. Then I have 5 by 3 to be able to get back my 15. And then I have 5 by 5, which can give me back my 25. So if you do this method, you definitely be able to work out the LCM of any list of numbers.